find radical expressions. So we're still dealing with radicals, but they're expressions, which means we have variables that we're working with. Okay, so we're going to start out by simplifying a real basic one, the square root of x squared. Christopher?
X.
You think it's just x? Why would you say that?
Because if you square something, it's x times x, and if you square root it, you go to the beginning.
Okay, so they're just inverses of each other. Squaring something and rooting something are just opposites of each other. If you think back to when you had the square root of 36, for example, that was the same as square root of 6 times 6, right? Which was the square root of 36 is just 6. It's what is being multiplied by itself. So that's what the square root would be. So the square root of x squared is the same as x times x, so the square root of x squared would just be x. Okay, what about the square root of x to the fourth? Think about what times itself would be x to the fourth. Raise your hand, please. Logan?
X to the second power?
Good, it would be x to the second power. Because x to the second power times x to the second power is x to the fourth power. Okay. Abby says, so are we just dividing the exponent by 2? Basically, that would kind of be how you're looking at it, yes. All right, so then the next one would be x to the third power. Very good. X cubed. Okay, no. Now I see what you're saying about this one. No, we're not going to just divide by 2 in this one. These, it worked out because they divided nicely by 2, right? Okay, a number of times a power, the same power. It just worked out that way. But in this one, you're going to want to break this up into x to the fourth times x to the first, which would be x to the fifth, right? So we're leaving it under the radical and we're splitting it apart. And then we can take this one out. This one comes out as what? X to the second power. But we still have x left inside, x to the first power, because it is not, basically the exponent is not divisible by 2. Yes?
How do you know what you're supposed to split it up into?
Well, you want an even number there. So you only want to have one left over. Yes?
Why don't you just do x to the 2.5?
Well, we're going to just be dealing with whole numbers as our powers for right now. We're going to deal with rational exponents tomorrow. But that would be a rational exponent. 2.5 is the same as 5 over 2. And we're going to deal with rational exponents tomorrow. Okay? All right, so let's look at the next one. So this one could be split up into x to the 6th times
X to the first.
x to the first, or just x, right? Okay, so then we write that as
X to the third.
x to the third, square root of
X. I got it,
just
sorry.
x, right? Are there any questions so far? We're taking the term that has the variable that can be divided by 2 out.
Why do you multiply by 2? You divide by 2.
Well, really, the reason they came up with that is because if you look here, x to the fourth is the same as x squared times x squared. And remember, with square roots, you're trying to figure out what times itself is that number inside. Well, x squared times x squared is x to the fourth. So it can come out of the radical as an x squared. Here, x cubed times x cubed is x to the 6th. So it can come out of the radical as x cubed. When you were doing problems yesterday and you had this, what times itself is 49? 7. So the answer was just 7. So here, what times itself is x to the 6th? X to the third times x to the third. So it comes out as x to the third.
No, it's x to the third times x to the third would be x. When you just
No, we're not. No. You guys are getting confused. X to the third times x to the third. When you are multiplying and you have same bases, you add the exponents.
Yeah.
So it comes out as x to the third. What are you multiplying by itself to get this? X to the third times x to the third. So it comes out as x to the third. What are you multiplying by itself to get 49? 7 times 7. So it comes out as 7. Okay. The next one. Let's break this one up. What can we break this one up into?
X to the 8th times x to the 1st.
X to the 8th times x to the 1st. So x to the 8th comes out as x to the 4th. And what's left in the radical? X. Maybe some more examples will help. Okay, let's look at this one.
Well, I understand how to do it. I just don't understand why.
Okay. Well, I
What's the point?
think that the more you practice, the better you will get, and the more sense it will make. Let's look at this one where we've got a coefficient right now. We know the square root of 4. What is it?
2.
It's 2, and the square root of x squared is just x. See, if you were to split this up, you could say that 2x times 2x is 4x squared, right? 2 times 2 is 4. X to the 1st times x to the 1st is x to the 2nd. So what times itself is 4x squared? 2x. 2x times 2x is 4x squared. So it comes out as the radical is just 2x.
So you can always take your work in
You can, yeah. Write it out twice. It's got to be the same thing you've written twice. Okay? Now this one, because this is not an even number, you're going to want to take the coefficient first. So what's the square root of 25? 5. Okay? And then remember, this can split apart into x to the 4th times x. So what's going to come out of the radical with the 5?
X squared.
X to the 2nd power. Good. Because remember, when it comes out, okay, and then we've still got the x inside.
Wait, hold on. But
So you can
before
get
you
X
put
out.
that in, oh, you didn't finish writing it when I looked at it.
Okay. Now
Can
you're
you get the X out? I don't
the x can't come out at the moment. I will show you tomorrow what we can do with variables that have exponents where it is not an even number here. Okay? Well, we're going to do that tomorrow. Let's just deal with this for right now. Okay? Let's look at the next one. 18 can break down into what? 9 times 2. Remember, you have to pick a perfect square. 9 is a perfect square, so 9 times 2 is 18. X cubed can break down into x squared times x. Okay, I would write it all like that. And then you say, okay, the 9 is a perfect square, and the x squared, those are perfect squares. Those are the two that will come out of the radical. So 9 comes out as a 3. X squared comes out as x. And then what's left inside? 2x. Very good.
Hold on.
Couldn't you divide that by 2 and bring it out?
No.
Can you explain to me how you got that from that?
Okay, let's one at a time. One at a time, because we are recording, so people who are listening are going to want to know what you're asking. So, what is your question? You need to say it louder.
Okay. Explain to me how, when you wrote the 9 times 2 times x squared times x, how did you turn it into 3x?
Okay, so you get why we have all of this, right? Okay, that's from yesterday, basically. The 9 comes out of the radical because the square root of 9 is 3. That's where the 3 comes from. The square root of x squared, which we just learned, is just x, because x times x is x squared. That's where the x comes from. And then the 2 and the x, the square root of 2 is not a perfect square, so he has to stay inside. Remember, he can't come out, remember that from the previous day, unless he's a perfect square. Same thing here. X to the 1st, that's not going to be a perfect square. So he stays inside with the 2. Okay, next. Let's look at this one. Oh, this one's nice because look, even though we have 2 different variables, what do you notice about their exponents?
They're even.
They're even. So we're going to be able to take both of them out, right? So the x to the 6, and if this helps, write it this way. X cubed times x cubed times y to the 4th times y to the 4th. Now remember, that's still all inside this radical. Okay, it hasn't come out yet. All right, but anytime you're multiplying something by itself inside, it can come out as just one of those terms. So out is going to come x to the 3rd power and y to the 4th power, and there's nothing left inside because when it's a number times itself, you bring it out as just one of those terms. Okay, what about the next one? This is going to be x to the 11th, y to the second. Okay, now this one isn't quite as easy because of the odd exponent, but we can break that down into x to the 6 times x. All right, the y squared is good though. So what's going to come out for my x? X to the third, and then how about the y?
Y to the second.
No.
Just y.
It comes out as just y.
Oh, because
It's y times y squared. And then there's still what? That x is still left inside. That x to the first power is still left inside. This will take some processing. You may need to go home and watch this lesson again. It won't hurt anything. Sometimes we just need a little extra dose. Okay, next. We need to break this apart into x to the 8 times x and y to the 10 times
X. Y, sorry.
y. Okay, so our answer is going to be x to the 4th. Take half of the 8. This x is going to have to stay inside. And then y to the 5th, and the other y is going to have, so inside I'm going to have x, y inside. Okay? Okay, the x to the 17th is going to break down into x to the
16
16
X.
times x, and then the y to the 14th is going to be good. So x comes out as x to the 8, the y comes out as y to the 7, and what is left inside? X. You guys got this. It just takes a little bit of practice and time. Okay? All right, let's do this one. How about the 4? Can he come out
Yes.
as a what?
2.
2. X to the 3rd, y to the 6th. You guys are doing well. You're doing very well. No, it's not bad. Okay. Now let's see if we can do these without having to write all these. Write it out. So 16 comes out as a 4. 4 times 4 is 16. Now, this right here is going to be 2 and 1, right? So x squared times x. So what's going to come out?
No, x squared.
X.
Just
X. Okay, scratch that idea. We need to write it down. All right. So what comes out?
X squared.
Just the x squared comes out, but as an x. It's just x. All right. And then inside we still have this other x, and
Y.
we still have the y because it was y to the first power.
Wait, hold on, but like, why do you put y on the inside?
Because it has a power of 1. It's got to at least have 2 or higher to be able to take it out. Yes.
Why'd you get rid of the squared?
Well, what times itself is x squared? X.
Oh, alright.
So you pull out the x. Okay, here, this one we need to break down. 4 times what? 4 times 6. X to the 7th, we're going to break up into,
X to the 6 times X.
okay, y.
To the 4th times X. I mean Y.
Y to the 4th times y.
Y, yeah.
Okay, now, the 4, if you want, circle the ones that can come out, if that's helpful. And the ones that aren't circled will stay inside. Maybe that's helpful. Just a suggestion. So the 4 comes out as a 2.
2.
X to the 6 comes out as x to the 3rd. Y to the 4th comes
Y
out.
to the 7th.
Y to the 2nd. And what's left inside?
6x, x, y.
6xy is still left inside your radical. Now, really, since we've got even exponents and we can take the square root of 49, we can just write the answer. We don't have to break this up. 7
X to the 4th, and then Y to the 2nd.
There you go. Very good. Okay, now this one isn't quite so simple. So 20 breaks into
4 times 5.
4 times 5. And if you weren't here on the previous day, we're choosing a number that's a perfect square, like 4, 9, 16, 25, all of those numbers that you can take square roots of. Okay, this is,
X to the 6 times X.
okay,
Y to the 8 times Y. Y, yeah.
y to the 8th times y. Very good. Okay, circle the ones that can come out. Those would be 4,
X to the 6 and Y to the 8.
Okay, so that comes out as
2x to the third and Y to the fourth.
then square root of
5xy.
Very good. Very good. Okay, why don't you try the last two and then look up here. If you're listening to the recording, pause the recording, try the last two, and then start it back up and check your work.
Oh, but there's a number.